learningspace.com.ng.
Hello, you're welcome to learningspace.com.ng. Let me be the first to welcome you to physics study. The first topic we're going to be looking at is measurement and unit. And of course, we're going to be looking at our local exams such as WAEC, JAM, NECO, PC, and the likes. So we're going to be using questions to explain all of this. Now on the screen, you can see the subtopics under the measurement and unit, which is the first topic in the JAM syllabus. So we're going to be using questions to explain all of those subtopics. Without wasting time, let me quickly introduce you to the first question, UME 2014, question 2. The question is on error in meter rule. Error in meter rule. The question is, what is the least possible error encountered when taking measurement with a meter rule? Least possible error. Now, to correctly answer that question, you need to know the smallest graduation in millimeter. The smallest graduation in millimeter is 1 mm. So the least possible error is half of this number, which will be 0.5 mm. So that will give you option B is correct. Okay, the next one is on micrometer screw gauge. On micrometer screw gauge, that was UME 2009, question 2. The question is Roman figure 1, diameter of a small ball bearing. 2, thickness of a piece of paper. 3, diameter of a measuring cylinder. Roman figure 4, length of a piece of wire. Now the question is, which of the above can be measured using a micrometer screw gauge? Now on the screen you can see a short note I've given on micrometer screw gauge. Micrometer screw gauge is used to measure the diameter of a wire or rod, thickness of lenses, external diameter of test tube, thickness of paper. You can see the short note on the screen. So the answer to this question is Roman figure 1, which is diameter of a small ball bearing, and Roman figure 2, the thickness of a pieces of paper. So that's option B, which is Roman figure 1 and Roman figure 2. So we'll move on to the next question. The next question we're going to consider is UME 2007, question 45. Now this question is on unit of quantity. The unit of moment of a couple can be expressed. Now before you can correctly give the unit of a quantity, you must know the mathematical expression. Now moment of a couple is mathematically defined as force times perpendicular distance, and force is Newton. The unit of force is Newton multiplied by the unit of distance, which is meter. So the unit of moment of couple is Newton meter. That is option A. Now I'll move on to the next question. The question is UME 93, question 1. The question is very simple. Which of the following quantities has the same unit as watts? Which of the following quantity has the same unit as watts? To correctly answer this question, you must know the quantity that have watt as its unit, and that is power. Power is force times distance over time. Force times distance over time. Now force is equals to, that's pressure, or power rather is force times distance. Now we can say force multiplied by distance over time. Now recall that velocity is of course displacement, if you like, over time. So if you combine this, you can remove this and put velocity there. So your power equals to F, which is force multiplied by velocity, if you remove V over T. So that's very easy to cope with. Now if you look at the option, force times time, that's option A, force times time. We are looking for force times velocity. B, force times distance, no. C, force times acceleration. And D, force times velocity. So option D is correct for that question. Okay, quickly, let us move on again to The next question, which is UME 1992 question 1. This question is on possible error in meter rule again, like we saw in UME 2014 question 1. We have what is the least possible error using a rule graduated in centimeter, using a ruler. That's what they are trying to say, a rule, that's meter rule, graduated in centimeter rather. Now, if you recall what I said the smallest graduation, of course, the smallest graduation you see for a meter rule is 1 centimeter. That's the smallest. So the least possible error is half of that very value, which is divide this by 2. You have 0.5 centimeter. Okay, now that will lead you to option B, which is of course the correct answer. Now, the same thing you do for vernier caliper, micrometer, screw gauge. When we get there, you see, whenever they ask you for the error in the measuring device, you look for you divide the smallest unit by 2 to get the least possible error. Okay, so quickly we'll move on to UME 1990 question 2. Now, which of the following is a fundamental unit? Which of the following is a fundamental unit? Now, before I roll out the option, let me just refresh your mind. We have fundamental quantities and we have derived quantities. Now, let's dwell on fundamental quantities. Fundamental quantities. That's my FQ, fundamental quantities. Now, the basic three is length or time, length, and of course mass. Then we have current, we have luminous intensity, we have amount of substance and the like. 7 of them, but these are the basic 3. Now the unit of time is seconds. The unit of length, of course, is meters. The unit of mass is kilogram. Now these are your basic 3 fundamental quantities, and the unit you give to it are their respective fundamental units. Now let me take you back to this question, UME 1990 question 2. Which of the following is a fundamental unit? A, Newton. B, watt. C, joules. And D, seconds. Mind you, they're asking us for fundamental unit, and the answer is what? Seconds, which is what? The unit of fundamental quantity, which is time. So the answer is D, seconds. Okay, I hope you're enjoying yourself so far. These stuffs are so very easy. Okay, now the next question we're going to consider is UME 88 question 2. The question is, which of the following are the correct SI units? Which of the following are the correct SI units of the quantities indicated? Now we have Roman figure 1, Newton. Is it the unit for force? Of course, that's correct. Then we have Roman figure 2, Newton per meter. And they have their torque. Torque. Is that the unit for torque? Obviously, that's wrong. That's not the correct unit for torque. Then we have watt, unit for power. That's correct. Then we have kilogram meter per second square. They wrote momentum in front of it. You can see the question on the screen. That is, of course, is wrong. The correct unit for momentum is kilogram meters per seconds. So the correct answer is option D, which is Roman figure 1 and Roman figure 3. Option D is correct for that one. Now, quickly, the next question is UME 87 question 1. You can see the question on the screen. On the screen is which of the following units is equivalent to kilogram meters per second? And the correct answer, of course, is Newton seconds, which is option C. Thank you very much. I'll see you in the next video.